Welcome to the UG students. Now we are going to that of the next video regarding the 2022 organic chemistry, and this is also helpful to the NEET and JEE guidelines. Now we are going to that of the first questions, that is the acid strength related problem. In the acid strength related problem, the malonic acids and the acetic acid, the pK value has been compared. In the pK value, first option is that the first pK of malonic acid is lower than that of the pK of acetic acid, while its second pK is higher than the pK of acetic acid. We know that the lower the pK value means that of the higher acidity. In case of the malonic acid, if we see that of the structures of the malonic acids has two carboxylic acids. After the first deprotonation, the carboxylate anions can be stabilized by that of the intramolecular hydrogen bonding effect. But the second deprotonation is very difficult, as that of the first, after the first deprotonation, the conjugate acid becomes stabilized and the hydrogen bond is involved for that of the second deprotonation. So the second deprotonation is very difficult in case of the malonic acid. Hence, the pK value of the first deprotonation of the malonic acid is lower than that of the pK2 value of the second deprotonation of the malonic acids. If we see that of the acetic acid, the acetic acid has no second deprotonation, that is the only one carboxylic acid is present. So the carboxylic group can be deprotonated to form that of the carboxylate anion. Here the hydrogen bonding is absent, so the pK value is comparatively lower than that of the after second deprotonation of malonic acid. So the option for the first option is that the pK of malonic acid is lower than that of the pK of acetic acid, while its second pK is higher than that of the pK of acetic acid. Means the acetic acid has higher acidity for the second deprotonation of malonic acid, but the first deprotonation of the malonic acid has higher acidity than that of the acetic acid acidity. Hence, the first option is the correct. Now, if we see that of the similar that of the basicity, if we see that of the basic properties, that is mainly examples of the proton sponge. It shows the higher basic strength. In case of the cis-cyclopropyl diamine, the 2NH2 group after the protonation, the conjugate acid becomes stabilized by the intramolecular hydrogen bonding. So the pK value for the cis isomer is greater, but in corresponding the trans isomer, the pK value is comparatively lower. Hence, if we say that of the similar type of the compound, where the proton sponge, that is the intramolecular hydrogen bonding, after the protonation becomes stabilized, and hence these compounds shows higher basic strength. Another examples for the acid base strength reaction is that of the negative annulation causes that of the lower acidity. In case of that of the Indian system, benzene ring with that of the cyclopentadiene, after deprotonation, the conjugate base becomes aromatic, but it has lower pK value. That is, it has higher acidity. When the benzene ring is more fused, the acidity becomes lower. That is, the pK value becomes higher. In case of that of the, with increasing the benzenes, the negative annulation causes that of the lower acidity. Negative annulation means the negative charge is conjugated more in that of the benzene, so the aromaticity of the cyclopentadiene ring becomes lost. So with increasing the benzene fused, the acid strength is decreases. Now the second problem is that of the JAM 2022 is the conversion of benzaldehyde to acetophenone. In case of the conversion of the benzaldehyde to acetophenone, there are different type of the reagents are displayed. One is that of the acylation reaction in presence of the aluminum chloride. Here the aluminum chloride produces the acylium carbocation, but the acylation occurs to that of the benzaldehyde beta to that of the CH group. We know that aldehyde group is meta reacting, but so the acetophenone is not formed in the first case. In the second case, if we see that of the second case, that is the thiol 1,3-dithiol, that undergoes protected from to produces the cyclic thioacetyl intermediate, and this cyclic thioacetyl intermediate on treatment with that of the N-butyl lithium produces the deprotonated species, and then this deprotonated species undergoes reaction with that of the methyl iodide to produces the protected form of the methylated form, and then after deprotection we get that of the acetophenone derivatives. Similar to that of the in presence of the methyl magnesium halide, the methyl magnesium halide can add to that of the aldehyde to give that of the secondary alcohol, and then this secondary alcohol undergoes pyridinium chlorochromate oxidation to produces the benzyl acetophenone derivatives. And this Ompalong strategy can also be helpful for the preparation of the bridging compound, and this is very interesting, that is made from that of the cladron, and in that the negative charge, if we electrosynthetic backward approach, if we see that the negative charge is created on the carbonyl group, and then this negative charge can add to that of the positive charge species and produces the bridging compounds, and this is more difficult for the synthesis of any other pathway. And the deprotection can also be occurs in case of the cyclic thioacetyl, the sodium iodate in presence of the metachloroperbenzoic acid. Here the sodium iodide and metachloroperbenzoic acid produces the oxidizing species, and which undergoes deprotection to produces the aldehyde groups. This is the actual mechanism for the deprotection, where the soft combination mercury can coordinated with that of the sulfur, and then the water molecule is added, and after that we get that of the aldehyde compound with that of the cyclic thiol compound. Next is the aromaticity, and if we say that of the aromaticity, in case of the aromaticity there are different type of the compounds are present. In case of the different type of compound, the aromatic and non-aromatic compound, after the cyclooctatetrene, the cyclooctatetrene undergoes tub shaped to give that of the non-planar species, and we know that this is the non-aromatic compounds. And similarly, this is that of the planar conjugated pi electron, and this conjugated pi electron this is the aromatic compounds, and these aromatic compounds, and this is the non-conjugated partially conjugated, this is also non-aromatic compounds. This is the planar compound, planar conjugated 6 pi electron, and this is the non-planar non-conjugated, that is the 2 hydrogen atom present in the small annular phase, so it is non-planar and non-conjugated. And this is the planar conjugated contain 6 pi electron by considering one lone pair on the oxygen atom, and this is not the cyclic compound, and this is the cyclobutadiene contain 4 pi electron, so it is anti-aromatic, and this is contain of 4 pi electron, this is also anti-aromatic compound. This is the non-planar and non-conjugated, so it is not considered as aromatic compound. Next is that of the this is the compound pyridine compound and the pyridazine compound. This is also considered as the aromatic compound. So the total number of aromatic compound is 5. Next is the addition or to allenes. In case of the addition to that of the allenes, we get that of the two type of the stereoisomer after HBr addition. We know that in case of the allene, the after HCl addition, it produces the two compound, but the former is the major, and the allylic conjugation here is not occurs, as that of the two p orbital present in the opposite orientation, so the overlapping did not take place. But in presence of the phenyl group or the methyl group, the overlapping will occurs and can stabilizes the carbocation 2 degree carbocation. So the benzyl carbocation becomes stabilized. But in that case, in simple allene system, this carbocation is more stable compared to this. That is, the allylic conjugation is not take place in case of the simple allene system. But in case of the substituted allene system, the allylic conjugation will occur, so it can be stabilized for that carbocation, and hence we get that of the two type of product after the HBr addition, and we get that of the two halides. One is the cis isomer, another is the trans isomer. So the two isomer is the compound. Next is that of the number of signal of the NMR spectroscopy. In case of the number of signal, we know that this is the different type of the signal is appear in NMR spectroscopy, and here the different in case of this is the biphenyl system, so the actrobiisomerism will occur. Here the methyl and methyl is in the same environment, and the paramethyl is the different environment, and the aromatic protons occurs in another environment. So we get that of the 3 signal for that biphenyl compounds. Similarly, this methyl group is present in the 1 carbon atom, but the arrangement of the methyl group is different. So we get that of the this methyl resonate at different region, and this methyl resonate at different region. This is the alpha pinene system, and this is the beta pinene system. Here the beta pinene system is more shielded, as this proton methyl group is resonate at the diamagnetic region, that is the shielding region, and this is the more de-shielding region. So the one same carbon atom does not mean that the methyl group is in the same environment. This is the rigid system, so the methyl group present in the different environment. This is the NMR spectroscopy of the nitromethane. Here the 3 signals is appear for that of the methyl, methylene and methylene proton, but the middle methylene proton is resonate at hex state instead of that of the instead of the quartet of triplet. Here the 12 lines is not appear, rather it gives that of the only 6 line by the n plus 1 rule, means 3 plus 2 plus 1 equal to 6, that is the 6 signal will appear. Next is that of the numerical problem. This is the limiting yield calculation, and if we treated with that of the 122 gram of benzaldehyde with 108 gram of phenyl hydrogen, gave 157 gram of the product, and what is the yield ratio? And we first yield is calculated from that of the mole ratio, and if we see that of the starting material mole is that of the 1.15 mole, but the reagent, that is the phenyl hydrogen, has 1 mole. So we always consider the lower limiting yield, means the lower mole percentage is calculated from that of the yield. So 1 mole converted to that of the 157 gram, if we converted to that of the mole, then the percentage of yield becomes 80%. That is the percentage of yield becomes 0.80 into 100, means 80% is the percentage of yield. Now this video is ended for the JAM questions 2022. Now next video is that of the upcoming video for GATE 2024 preparation. Thank you.